Okay, so let's go ahead and jump right into it. So when it comes to this idea of drat, I currently still have issues trying to process what the heck does drat mean. Well, drat is the real axle ratio, and it measures how many times the drive staff, okay, turns compared to the rear wheels. I still don't understand it. Okay, for example, a rear ratio of 3.5 means that for every 3.5 rotations of the drive shift, the rear wheel wheels turn once. I guess that makes sense. Let's read it on. Okay, let's actually make this look fancy. I don't know why I'm not in fancy mode. Um, all right. The ratio is important because it affects the car's performance and fuel efficiency. A higher rear axle ratio can provide more powerful acceleration, but may use more fuel. While lower ratios can give you better fuel efficiency, but may result in slower acceleration. Now that's counterintuitive because I know what's going to happen in our model. Well, we'll see what happens. So it's all about finding the right balance for what you want. All right, so that's according to Chat Geppetto. That's my new name for Chat GPT. Chat Geppetto. So model one, let's go into it. So I'm going to use drat. So that's why I did that digression. I'm going to use drat to predict our miles per gallon. So in a simple linear regression model, we're going to use miles per gallon as our that's Control F or Command F. That's going to use what am I doing with my life? Do this Control F. It's not letting me do it, but this is going to be miles per gallon. That's wasted 20 seconds. Miles, MPG. And then for every single place that we see the Y variable, we'll put miles per gallon. Okay. For the correlation, it doesn't matter, but everything else it does. You need to make sure you put it in that right order. And then this is going to be DRAT. So let me try it again. Let me try this again. So I'm going to copy and paste this. Copy, paste, copy. And I'm going to put this into Control F. Okay, that's fine. They don't want to help me out. Because of the time, I don't want to make this video 20 minutes. I'm going to just do this. Okay. So replace. Has another place, but I'll come back to that. So our summary of our data will look something like this. Okay, I'm patient. I'm sorry. Okay, this is where it says, that's why it's kind of counterintuitive in terms of the correlation, because what's happening is as drat increases, the miles per gallon increases. The miles that's a better fuel efficiency. So that's what made me kind of confused about that, according to ChatGPT definition of drat. All right, so we have the mean of y and the mean of x, so on and so forth. What we can then do is look at the visualization. Again, this is simple, linear regression. Okay, and replace this. Okay, boom. And then when we visualize this, it's not horsepower. It's drat, our rear axle ratio. Okay, we post this. And I don't have to change this to make it work, but kind of want to make you all impressed. Okay. So this is my visualization. That's cool. Interesting. So again, as x increases, y increases. Now, hopefully, I don't know if you want to do this, but you can change the colors if you want to be fancy. Okay. Then let's just run the model. Okay, let's run the model. So this is going to be, again, miles per gallon. Okay. Erase. Make sure you erase that caret. My bad. And then replace this. Jeez, so excited. Okay, boom. And then from there, you can get your regression coefficients, your standard deviation residuals, your R squared. You should be a master at getting this information. Okay. And note that the p-value right here indicates that drat can predict. There is a linear relationship between drat rear axle ratio in miles per gallon. Okay, let's keep going. Then what I'm gonna do just for funsies to make our life easier, I'm gonna do all for this one. Okay, you could have done that. Oh, how come I didn't do it? Because it's being sensitive. Okay, all. Okay, good, got it. And I'm gonna do the same thing for y variable. You could do that in general. I mean, the part of the process of learning is going through it. You know what I mean? Let's do all. Okay, good. So in this particular line of code, I'm just changing up VS. So VS stands for, I believe, engine. It's engine. It's engine. Okay, it's either V-shaped engine or a straight engine. Okay, there's only two types of engines. Okay. With that being said, we can go ahead and run this, and this will give us what the mean and standard deviation and min-max are for both of the engine types. Okay, so this is important in terms of our predictions, which is, you know, we discussed this before in class. Continuing on with the same framework of thought, I wouldn't necessarily go into detail here, but we are creating two regression lines. Okay, we're creating two regression lines, but here, model 2, you see that they are parallel, right? That means they're the same slope, so therefore this is the dummy variable model. I don't know why I do that sometimes. Dummy variable model. Okay, so that's that. That's cool. And then you can change this to, I'm not going to change it here, but this should be drat if you want to be rear axle ratio. Okay. And you can do that there as well. Just like it looks, so whatever you say in the description is accurate. All right. So there we go. But, you know, just in terms of predictions, you can look at this a little bit and say, well, maybe the y-intercepts are different, right? You can kind of see it a little bit. This only has these 4 points, whereas these points are, the pink points are traditionally below. And you can then run the analysis, and I guarantee, I think it's gonna be significant. Okay. Yeah, this is going to be significant, indicating a difference in y-intercepts. But look at this though, right? The slopes look the same. They look the same. So when we do the interaction variable model, let's see what happens. Okay. So that's that. When we do the interaction variable model, this is technically the same code. You don't necessarily the same exact information. The visualization, the only thing that's a little bit different with the visualization, yeah, it's trying to account for the different slopes. But even here, like, yo, this is the same. This is the same slope. All right, but I want to know what's going to happen regarding it, because it's also going to test for different y-intercepts. So let's see what happens there. It's kind of exciting, right? All right, so let's see what happens there. You see, this is a problem. So this coefficient is for the different y-intercepts. I mean, different slopes, and then this with the colon in it. Okay, and then this is testing for different y-intercepts. Look what's going to happen here. So this is what we call overfitting, and I didn't emphasize this in this class. In 324 you would, in other fact classes you would, machine learning you would, but there's times when you can overfit the data and it becomes less generalizable. This is a version of that, and now it looks like as if the y-intercepts are not this. The y-intercepts are the same based on how we're modeling it. But in reality, you know, obviously in the other model, the y-intercepts are different. Okay. And so it's really about just making the best kind of predictions. Again, this is not a question. Well, this is not a question on the lab, but I just saw the opportunity to teach. So be careful when you're selecting models in real life. All right, have a good day. Bye.